We're going to start the last section of chapter 1. So section 1.8 is about exponents and order of operations, and it starts on page 88. So this is an important section, and with that we're going to be able to have all the tools that we need to do our algebraic computations from now on. So section 1.8 is about this exponential notation. So we have here two numbers represented with letters. So we have this number b and this number n. So, and this number n is on top of number b, slightly off. So, and we call this an exponential notation. And what is an exponential notation? It's just another way to express a multiplication. So when you see this, what you are seeing is just a multiplication. What kind of multiplication? Okay, the definition of an exponential notation is that in this case, b is going to multiply itself. So b is going to multiply b. How many times is it going to multiply b by itself? As many times as the exponent indicates. So the exponent only indicates the number of times that b is going to multiply by itself. So that's the exponential notation. So, and these numbers receive names. So this number is going to be known as the base. That's the reason we are using b. And this number is going to be known as the exponent. So we have the base, we have the exponent. And all together, we can call this a power of b. So there are going to be many powers. So let's say that we have 2 and we have 3 as the exponent. So my base is 2 and 3 is the exponent. And now that we know the numbers, we can write the equivalent multiplication. So in this case, this exponent is saying that the base multiply itself 3 times. So you're going to have the base times the base times the base. That's the meaning of this number 3, that the base multiplies by itself 3 times. So what is the base? The base is 2 times 2 times 2. So when you have 2 to the third power, what you do is you multiply 2 by 2 by 2. So 2 by itself 3 times, and then the answer is going to be 8. So in this case, n was equal to 3. So when n equals to 3, when the exponent is 3, you say that you are getting the cube, or that you are cubing. So, and when n equals 2, when the exponent is 2, you're getting the square, getting the square, or that you are squaring. So that's the most common cases when you have n and you have n equals 3 and n equals 2. So in this case, you say 2 to the cube, 2 to the third, 2 cube, or the cube of 2. So there are those terminology. So you can say this is the third power of 2. So this is a power of 2. So we're going to solve an example on how to use this notation, the exponential notation, to understand many things. So we're going to start with example 1. Example 1 is on page 89. And it's just we are just gonna evaluate. We're gonna evaluate, and we have first 4 to the second power, or 4 square. So how do you evaluate this? You need to rewrite the exponential expression as a multiplication. So this is going to be the base. So we write the base, and the base is going to multiply the base. How many times? Just the number of times that n indicates. So n, the exponent, indicates that 4 should be multiplied by itself 2 times. So 4 times 2. So 2 times. So 4 multiplies 4. So the answer is just 16. Then we have B, the next part of the example is -5 to the third power. So here the parenthesis is very important because the parenthesis is telling you that the base is -5. The base is -5, so that means that the base is -5 is going to multiply itself how many times? 3 times. So we're going to multiply -5 by itself 3 times. Now, remember the rule of signs. So when you have an odd number of negative numbers, then the result is going to be negative. Then you just have to multiply 5 times 5 times 5, the absolute values. So the answer is going to be -125. Okay, that's one more problem. Then we have -2 to the 4. So -2 to the 4, again, the parentheses indicate that the base is -2. The base is negative. So this means that we're going to multiply -2 by itself, so by -2. How many times? You look at the exponent. It says 4. Then I need to write 4 times -2. So now we have an even number of negative numbers. So that means that the answer is going to be positive because you have an even number of negative factors. So then you just need to multiply the absolute values. So the answer is going to be positive 16. And finally, we have one more example, or one more case with respect to this example. And this is -2 to the 4. So this is very important, a very important exercise because you're going to distinguish now the importance of the parentheses when you have exponents. So in this case, the number 4 only affects the number 2. It doesn't affect the negative sign because it's not enclosed in parentheses. So in this case, 4 only affects 2. In this case, 4 affects -2. So the base is just 2. The base is just 2. In this case, the base is -2. So that's important. In this case, the base is -5. So in the first case, the base was only 4. So you need to check what number the exponent is affecting. In this case, it's just affecting 2. So that means that we're going to keep the sign there, but later we're going to write just what corresponds to 2 to the 4. So 2 to the 4 indicates that the base is going to multiply itself 4 times. But the sign that precedes the exponential expression should be there. You're going to use this sign after you finish the multiplication. So this multiplication is going to give you, again, 16, but now the sign, the negative sign, remains. So that's example 1. So let's use now this exponential notation to solve or to simplify algebraic expressions. So we're gonna have now example 2. Example 2 is about the importance of exponent and algebraic expression. So you have exponents and algebraic expression. So this is important because exponents help us identify like terms. So this is important, very, very important when you are simplifying algebraic expression. This is important when you are simplifying algebraic expressions, because you're going to be able to combine like terms, and you know that you combine like terms. Like terms are terms containing variables with the same exponent, so at the same power. So we're going to work now example 2. Example 2 is on page 99. So we're going to simplify. So we're going to simplify. So the first part is just 7x cubed plus 2x cubed. So you can see here you have the variable is x, the exponent is 3, the variable x is x, the exponent is 3. So these are like terms because they have variables at the same power. So you can combine them. So you combine again just the coefficients. So 7 plus 2 is going to be 9. And the variable is x to the third power. We have now 5x squared plus x squared. So are these like terms? Yes, they are, because I have the variable x to the second power, the variable x to the second power. So both terms have the variable x at the same power. So they are like terms. So we can combine these two terms by adding their coefficients. What are the coefficients? So the coefficients in the first case is 5. In the second case is just 1. So when you don't see a coefficient in front of a variable, the coefficient is 1. So you add these two numbers, you're going to get 6. And the variable with the corresponding power is x squared. Now the last problem. The last problem is going to be 3x squared plus 4x cubed. Are these like terms? No, because this x is raised to the second power and this x is raised to the third power. So these are not like terms. So no like terms here. So that means that you cannot do more than just leaving the expression that it is. So that's the answer for this case. So you just leave it as that. So now we're gonna start working. We're gonna try to understand the order of operations. So the order of operations is in your book on page, let me see, page 99. So on page 99, you see the order of operations section. And on page 92, there is a green box with a summary of how to proceed with the order of operations. And the rules are the ones that I just wrote here. So this is order of operations. So these are the steps. So first, you're going to perform all operations within grouping symbols. So what are the grouping symbols? Parentheses. So you have one parenthesis opening that opens and closes. So everything inside should be reduced to the simplest expression. So this is a grouping symbol. This grouping is enclosing something. You can have also square brackets, or you can have curly braces. So these are grouping symbols. You need to solve, you need to perform all the operations that are within these grouping symbols. Once you finish that, you're going to continue evaluating all exponential expressions. So that's the reason we needed to know before about exponential expressions. So you need to remember the rules for exponents. And most importantly, you're going to need to rewrite exponential expressions as multiplications, because that's the best way to proceed to simplify, to perform indicated operations. Then the last two steps are, first, you're going to multiply and divide from the left to the right. That's the order. Multiply and divide from the left to the right. And then there is a similar rule for addition and subtraction. You're going to add and subtract from the left to the right. But in this case, we can do it in a different way. You can also group all the positive quantities and group all the negative quantities, then add them up, and then at the end you're gonna end up with addition of two numbers or two quantities with different signs. So those are the steps to follow when we are working or trying to simplify an algebraic expression. So we're gonna work some examples, and we almost finished this section, and with that we're going to finish the chapter and the lecture. So we have example 3 on page 92. So this is just about simplifying. So we're going to simplify 18 plus 2 times 3 minus 10. So your book uses this central dot notation to indicate a multiplication. I don't like that notation because sometimes we can make the mistake and think that this is 2.3, which is a different number. So the best way to deal with these issues is that you immediately write the multiplication by using parentheses. So once you do that, we're going to start applying the rules. These are not the parentheses that are grouping something, because there are not something, there are not several terms inside of a parenthesis. The parentheses are not used to group terms. So these parentheses are used to indicate multiplication, so be careful. So we're gonna start then. There are no grouping symbols. There are no parentheses used as grouping symbols. There are not exponential expressions. So we're gonna start right away with this. With step 3, we're going to multiply and divide first from left to right. So the only thing is that there is only one multiplication here. So we do that step. 2 times 3 is going to be 6. So here, then we're going to apply the multiplication from left to right. There is only one. So 2 times 3 is 6. Then the next is we're going to add and subtract from left to right. So we need to add 18 to 6, and then we're going to subtract 10. Or you can group positives and negatives. So let's do that now. I have here my positives. I have here my negatives. So my negatives is just negative 10. Positives is going to be 18 plus 6 is going to be 24. So we have 24. That is a positive quantity, and 10, which is a negative quantity. The last step is just adding two numbers with different signs. So you remember that you do this by subtracting absolute values. So we're going to end up with 14, and then you keep the sign of the greatest. The numbers with the greatest absolute value is this one. So the answer is just 14. So that's example 3. So let's work now example 4. So example 4 is on page 92, and it's going to be about simplifying another expression. Now we have 6 to the second power minus 24 divided by 2 to the second power times 3 minus 1. So this is the expression. So we're gonna look for parentheses. There are no parentheses here, so we look for exponential expressions. So we're gonna rewrite and reduce exponential expression. So we have 6 square means that 6 multiplies itself 2 times. Then we have negative 24 divided by, and then we have 2 to the second power, meaning that 2 is going to multiply itself. And then we have times 3 minus 1. So I need to work first with the exponential expression. So these are the multiplications corresponding to the exponential expressions. This one and this one. So this is going to be 36 minus 24 divided by 4 multiplied by 3 minus 1. So that was the first step. Now, the second step, we look for multiplications and divisions. So we're going to multiply and divide from left to right. So where are those? We have this section here where you have multiplications and divisions. So the first one is 24 divided by 4. So that's the first step. So 24 divided by 4 is going to be 6. And then we have a multiplication by 3. So we work first the division because it's the first one that appears when you go from left to right. And then we continue to the right, and then you proceed with the multiplication. This is important. You start from left to right, and the first symbol when you start from left to right is a division symbol, and then a multiplication symbol. So that means that you go first with the division and then with the multiplication. So that's the reason I'm dividing first. 24 by 4 is 6, and then you multiply. This is going to be 18, and then you keep the sign that you have before, then you write the remaining terms. So this is 36 minus 18 minus 1. The last step is you're going to add, subtract from left to right. But again, we can combine first positives and negatives, so that's what I'm going to do, or combine positive and negative terms first. So I'm going to combine the negatives and the positives. So I have only 36, which is positive. I have 2 negatives, 18 and 1 is 19, and they are negatives. So now the last step is just doing this addition of 2 numbers with different signs. So this is 36 minus 19. So this is going to be 17. And we're going to keep the sign of the number with the greatest absolute value, which is this. So the sign is positive. So that's example 4. We're going to continue with more examples. So now we go to page 93. On page 93, we have example 5. Example 5 on page 93 is more simplification. We're going to simplify first. We have 2 times 5 square. So here you have, this is the base and this is the exponent, but we have a grouping symbol here. We are grouping 2 numbers here. So we're going to start with first we work on parentheses first, so the grouping symbols. So 2 times 5 is going to be 10. Then we have square here. Then we're going to proceed with exponential expressions. So to solve exponential expressions, you just need to rewrite the exponential expression as a multiplication. So you know that the base is 10. So you're going to multiply 10 by 10. How many times? Just 2 times. So it's just 10 times 10. So this is going to be 100. And that is going to be the answer for this part. Then we have another part here. So we're going to have now 2 times 5 squared. So you can see here now the importance of parentheses, because in this case the base was 2 times 5. The base. So this is the base. 2 times 5. In this case the base is only 5. The base is only 5. 2 times 5 is 10. So that's the reason we got the base equals 10 in the previous example. In this case, the base is 5, and we need to start first with exponential expressions. So in this case, we have 2 times something. That something is 5. That multiplies itself 2 times because the exponent is 2. So this is going to be 2 times, and 5 times time is 25. Finally, we end with multiplication. In this case, we're going to multiply from left to right, and we have the only thing that we have is 2 times 25 is going to be 50. So the final answer for example 5, part B, is 50. So now we're going to work one more example. Then, yeah, we have 3 more examples to work on. No, 4, before giving you the first set. So let's work on those examples because this is important. This is how we proceed when we have to use the order of operations. So we're going to work example 6 now. Example 6 is on page 93. So more simplification work. So we have now fractions. 1/2 to the 3rd power minus 1/2 minus 3/4 to the 2nd power times -4. So this example is very interesting because you can see here how the parentheses have different meanings. So in this case, the parenthesis is just enclosing the base of this exponential expression. Here the parenthesis is just indicating this is a factor that multiplies this exponential expression. And in this case, the parenthesis is used as a grouping symbol because it's grouping the operation of two terms. So this is the parenthesis. This is parenthesis. This is the parenthesis that shows a grouping that is used as a grouping symbol. So this is parenthesis as a grouping symbol. This is important because the rule says work first with the grouping symbols. So this is not a grouping symbol. This is the grouping symbol because it's enclosing 2 different terms that are affected by this operator. So we have the addition of 2 quantities, 2 fractions with different signs. So that is going to be the first step. So we're going to work on grouping symbols first. So we're going to leave 1/2 to the 3rd minus, and then we're going to start working with this. So we have 1/2 minus 3/4. So we need to multiply 1/2 by 2 to get the same common denominator. We can use now a different grouping symbol because you can just change the grouping symbol. They are used for the same purpose. And I am doing that because now I have parentheses here that are used for different purposes now to indicate multiplication. So I'm just switching from using a parenthesis as a grouping symbol to use square brackets as a grouping symbol. So let's continue. So I have 1/2 to the 3rd power. Then we're going to have 1 times 2 is going to be 2. 2 times 2 is going to be 4. Minus 3 fourths, and then we can get back our parentheses as a grouping symbol. Square, -4. Now we can proceed with this operation here. So 2 fourths minus 3 fourths. So these are the addition of two different, the addition of two numbers, two fractions with different signs. So you're going to subtract numerators. So you're going to have a common denominator. You're going to have 2 minus 3 squared times -4. And now 2 minus 3, you just do 3 minus 2, right? Is 1. But you're going to keep the sign of the number with the greatest absolute value. So you're going to get -1/4 squared. That multiplies -4. We have a negative sign here, and we have 1/2 to the cube. So we finished the first part. So now we have to work on exponential expressions. Now that's the next step. So we're gonna reduce, we're gonna simplify exponential expressions. So we have 2 here. So the first one, the base is 1/2 and multiplies itself 3 times. So that's this one. Then I have negative. Then I have this new base, -1/4, that multiplies itself. Only the multiplication is 2 times. And finally, times -4. So now we're gonna proceed and finish our work with the exponential expression. So this is gonna be 1 times 1 times 1 is gonna be 1. 2 times 2 times 2 is gonna be 8. Then here we have this negative sign. This one, you will need to be very careful. This negative is this one. Then we have these two negatives. So negative times negative is gonna be positive. We can just write positive. 1 times 1 is 1. 4 times 2 is 16. So this is the result of multiplying -1/4 by itself. And finally, -4. We still have here multiplications to do now. So the third step is going to multiply from left to right. So we leave 1/8 here. And now we're going to finish this part. So we're going to multiply these two quantities. So to multiply these, we need a fraction here. So we're going to have -1/16, -4/1. Remember, that's the way that we multiply fractions. So we need the second number to be a fraction too. So now we're going to finish this part. So we have 1/8, then minus, then we have 16 times 1. Before multiplying, remember we need to look for common factors and divide by the common factors both the numerator and the denominator. So we're going to divide this by 4, and we're going to divide this by 4. They have this common factor, so we're going to end up with 1 that multiplies -1/1. Here, this 16 divided by 4 is 4. So we have Finally, 1 over a minus, then we can finish now this part. Negative 1 times 1 is negative 1 over 4 times 1 is going to be 4. So the last step is just doing this multiplication. You're going to have negative times negative is going to become positive. 1 over 4, we have 1/8 here. So we're going to add now these two quantities. So to add these two, we need to multiply both the numerator. I'm going to write this here, 1/8 plus 1/4. We're going to multiply by a number that is going to give me the same denominator. So I need to multiply by 2, both. So I'm going to get 1a plus 2 times 1 is 2, 4 times 2 is 8. So now I have the same denominator. So the final answer is going to be just 2 plus 1 over 8. So this is going to be 3 over 8. So this is a long problem. But it's important because you saw all the different steps that we needed to perform to get to the final answer. So that's example 6. Now we're going to work example 7. Example 7. It's on page 94. So example 7, we're going to simplify. And we have a lot of grouping symbols. We have 2 times that multiplies 5, that multiplies 4 minus 7 plus 9, and then. So we have different grouping symbols here. So these are nested grouping symbols. So these are nested grouping symbols. And when you have nested grouping symbols, you're going to start from the innermost grouping symbol. So you need to identify what is the core of this nested group. So you can see that the parenthesis is the innermost in this case. So we're going to start with the parentheses. So we're going to work first here. We're going to simplify this, 4 minus 7. 4 minus 7 is just the addition of two numbers with different signs. So you're going to subtract 7 minus 4 is 3, and you get the sign of the number with the greatest absolute value. So it's negative. So that's this parenthesis. So you write the rest. So now we need to continue with this symbol now, this grouping symbol. To simplify this grouping symbol, we need to perform the operations that are inside. So first we have a multiplication, so we're going to proceed with that. So we have positive times negative is going to be negative. 5 times 3 is going to be 15, and then you have positive 9. So we haven't finished yet, so we need to proceed with this addition. So this is the addition of two numbers with different signs. So you're going to do 15 minus 9 is going to be 6, but you need to keep the sign of the number with the greatest absolute value, which is negative. So you end up with this quantity times negative 6. So positive times negative is negative, and 2 times 6 is going to be 12. So that's example 7. So now example 8 on the same page. It's going to be a long list of operations. So we have 18 divided by 6 plus 4 that multiplies 5 plus 2 times 8 minus 10 to the third power. So this is the expression that we're going to simplify. So we go here because we have these square brackets indicating that this is a grouping symbol. So we're going to work with the information that is inside. Inside we see an addition, and we see an exponential expression, and we see another grouping symbol here. So this is the innermost grouping symbol. So we start from here. So 8 minus 10. So that's the difference of two numbers. So it's going to be negative 2. So we just did 10 minus 8 is 2, and the sign of the number with the greatest absolute value is 10, so it's negative. So this is this parenthesis, we write the rest. We try to keep the same information. We need to write everything. This is important because sometimes we are lazy and just work on pieces of the expression, and at the end we result with a wrong answer. So now we need to continue. Now we're going to evaluate this we're going to evaluate this exponential expression. So we're going to write negative 2, which is the base, and it's going to multiply itself 3 times. So I'm working now with this part. So this is going to be negative times negative times negative. It's an odd number or negative number, so it's going to be negative the answer, and 2 times 2 times 2 is going to be 8. So you're going to replace this portion by negative a, or with negative a. So we're going to write negative 8 that multiplies 2 plus 5. So I'm going to write everything again, the remaining part, to prevent mistakes. So we continue. We are working with this square bracket. So now we have to work with this part, multiplication. So positive times negative is going to be negative. 2 times 8 is going to be 16. And then we write the rest. Don't forget the rest. We need to write in every step the remaining part. The final part is an addition inside of this square bracket. So this is going to be 16 minus 5 is going to be 11. Now, what is the sign of the number with the greatest absolute value? Is negative. So this is going to be negative 11 multiplying 4. Okay, now we're going to start solving multiplications and divisions from left to right. So we're going to start from left. 18 divided by 6 is going to be 3. And then we have this plus here, and 14 times negative 11 is going to be negative 44. So finally, positive times negative is going to be negative. So you're going to have 3 minus 44. So you're going to get the difference of the absolute values. The difference is 44 minus 3 is going to be 41. And then you keep the sign of the number with the greatest absolute value, which is this one. So the answer is negative 41. So that's example A. I'm going to solve one more example, and then I'm going to assign you the first set of problems corresponding to this section. So we're going to solve now example 9. So example 9. Example 9 on page 95. So this is going to be another long problem. So we're going to simplify 2 times 3 minus 12 plus 6 times 4 over 2 to the 4 plus 1. So that's the problem. So we're gonna have, this is a fraction. So we're going to work the numerator and the denominator independently. So in regards with the numerator, we have a grouping symbol here. So we're going to work on this part. And in the denominator, we have this exponential expression. So let's simplify that. 3 minus 12, this is the addition of two numbers with different signs. So you're going to do 12 minus 3 is going to be 9, and you're going to keep the sign of the number with the greatest absolute value. So the number is negative. So then you have 2, and then you have 6 times 4. I don't like the dot notation. Okay, that's the numerator. The denominator, you have 2 to the 4, so the base is 2, and the exponent indicates that we have to multiply 2 by itself 4 times, and then plus 1. So from here, you can see that we proceed with the multiplications from left to right. So we have 2 times 9 is going to be negative 18 plus 6 times 4 is going to be 24. Here you have 2 times 2 times 2 times 2 is going to be 16 plus 1. And finally, 24 minus 18 is going to be 6. And it's going to be positive because the number with the greatest absolute value is 24 and is positive. And finally, 16 plus 1 is 17. So that's the answer for example 9. So now you're going to work on 1.8, exercise set on page 99. So you're going to evaluate each exponential expression. So we have problem 6. This is negative 10 squared. 14 is negative 8 squared. Then you're gonna simplify. 18 is 14x to the cube plus 8x to the cube. 20, you have 14x to the 4 plus x to the 4. 24 is 30x to the cube minus 29x to the cube. 26 is 8x to the second power plus 8 to the x to the third power. And finally, 28 is 34x squared minus x squared. Then you're going to use the order of operations rules to simplify each expression. So we have 34 is 8 times 6 divided by 2. 38 is 10 squared minus 100 divided by 5 squared, multiplying 2 and then subtracting 1. Then you have 44 is just 4 minus 6 squared minus 5 minus 9 squared. Then we have 50. This is 3 times 4 plus 3 times 10 minus 8. Then we have 58. So it's a lot of work, but this is important. This is important for what is coming next. So negative 5 that multiplies 7 minus 2 minus 3 that multiplies 4 minus 7 over negative 13 minus 5. And finally, 66 is going to be 30 divided by 5 squared over 7 minus 12 minus 9. So from this set, at least I want these problems that you should work on. So we have 2 more examples that I'm going to cover, and I'm going to assign you a final set of problems. So these problems are about evaluating algebraic expressions. So let me go directly to that to finish our lecture today. So we have example 10, page 95. So it says that we're going to evaluate negative x squared minus 7x for x equals negative 2. So you remember when you evaluate an algebraic expression for a given value of the variable, what you're going to do is just you're going to replace the variable with that value. So you're going to replace x with negative 2 in this case. So the most important step is that you're going to use parentheses to replace the variable. So this is important. The x is going to be negative 2 and then the exponent. This is important that you use parentheses because the variable is the base, and the base should be the number that is provided, in this case negative 2. Then you have another sign outside of the variable, in front of the variable, so don't forget that sign. Then we have negative 7 here, and we're going to use another parenthesis for the variable x, and we're going to use negative 2. So this is important. I'm going to write this here. So you're going to replace every x with a parenthesis. So this is the importance. So you're going to replace each variable with a parenthesis. This is important. Otherwise, you're going to make mistakes. Once you get this is a simple process because this is what you have been doing so far. So you're going to start, again, applying the order of operations. So we're going to start here by solving the exponential expression first. So we have this negative here. Then we have the base that multiplies itself twice because it's what the exponent indicates. Then we have negative 7 that multiplies negative 2. So we finish first with this part because this is the part that we are working first because that's the order of operations. So we have negative 2 times negative 2 is going to be positive 4. And we have a negative sign here. We have negative 7 that multiplies negative 2. Then we proceed with multiplication. So negative times positive is going to be negative 4. Negative times negative is going to be positive. 7 times 2 is going to be 14. So finally, we have the addition of two numbers with different signs. So you're going to do a subtraction. 14 minus 4 is going to be 10. And you're going to keep the sign of the number with the greatest absolute value. In this case, is positive. So that's the first example. And the final example of this lecture is going to be example 11. Example 11 on page 96. So we're going to simplify. We're going to simplify 18x squared plus 4 minus square brackets 6 multiplying x squared minus 2, then plus 5, and we close the square brackets. So let's see. We're going to work with the innermost grouping symbol. This is the innermost. We're going to apply the distributive property because we cannot combine these two. They are not like terms. So the only thing that we can do is apply the distributive property here. So we're going to have 6x squared, and 6 times negative 2 is going to be negative 12. So this is the result of this. So we're going to use this square brackets here, the negative sign here, plus 4 and plus 18x squared. Now we continue with the grouping symbol. So we're gonna work here. So you can see that these two are like terms, so we're gonna combine them. So this is the addition of two numbers with different signs. So this is gonna be 12 minus 5 is gonna be 7. And we're gonna keep the sign of the number with the greatest absolute value, which is negative. Then we have 6x squared. And then we have this negative here, 4 and 18x squared. Now, we need to remove this square bracket, so we're going to apply the distributive property here. So you're going to multiply negative, we're going to apply this negative sign over these terms here. So we start negative times positive is going to be negative 6x squared. Negative times negative is going to be positive 7. And then we end up writing the rest. So we are almost finished this problem. We look for like terms. So this one and this one are like terms. So let's work this. These are like terms. So we have 18 minus 6. Remember, we work with the coefficients. And 18 minus 6 is just 12 and x squared. Then we write the rest. We have plus 4 plus 7. It turns out that these are also like terms. So you can add them up. You're just gonna get 7 plus 4 is gonna be 11. And you write the rest. And this is the final answer. So I'm going to give you 6 more problems to finish the section, finish the chapter. So now you're going to be able to work on homework 1 and also on quiz 1. So homework 1 is going to be just a set of problems for you to review the chapter. And quiz 1 is going to be also a review of problems, and you're going to get immediate feedback when you finish you're going to get a grade immediately when you finish the quiz. And remember, if you don't get all the answers correctly, you can check where you didn't get the right answers, and you have a second attempt, so you can work on that. So let's see. We have on page 100 the next part of the 1.8 exercise set, page 100. So you're gonna evaluate some problems. This is important. You're gonna evaluate. So we start with problem 74. So you're gonna evaluate x squared minus 2x when x equals 6. Then we have problem 76. You're gonna evaluate 4x squared minus 2x when x equals negative 3. Problem 78, you're gonna evaluate negative x squared minus 14x when x equals negative 1. Then we have problem 80, and this is 3y minus 2y squared over y that multiplies y minus 2, and you're going to evaluate this when y equals 5. So this is a very important set of problems because this is the crucial part to be able to continue successfully this course. So you're going to work on problem 86. You're going to simplify 6 minus 5 that multiplies a minus 2y minus 4. And finally, 88 is going to be 4 that multiplies 6x squared minus 3 minus 2 that multiplies 5x squared minus 1 plus 1. So all these problems are required for you to submit. You use your phone to take screenshots of your work corresponding to this lecture. Use CAM scanner or PDF scanner to get a PDF file, and then you upload that by using the submit button in classwork 1D. And as I mentioned before, you are ready to take the quiz, and you also are ready to complete homework 1. So remember, you're going to have only one homework per chapter, only one quiz per chapter. This is the end of chapter 1.